Okay, complex numbers. So we went over radicals and all that stuff. Complex numbers kind of fall out of radicals. Okay? So, complex, you should have learned last year about the imaginary unit. Okay? So, and it's defined as -1. And imaginary is kind of a bad name for this because there are lots and lots of applications for imaginary numbers. Okay, I know that it's used in like astrophysics and it's used in a lot of there's like rubber, the way that you like can stretch rubber, like you use the imaginary unit. So like there's the complex number plane that it's imaginary, but it's more just like you can't see it, kind of. I guess I don't know. That's probably not the best explanation, but yeah. Anyways, so imaginaries are defined as the square root of -1 because we know that you can't take the square root of negative numbers. Okay. Pure imaginary number is written in the form as a plus bi, and let's call these complex. We're not going to call these imaginary. We're going to call them complex. Okay. So it's a plus bi, where a is the real number and b is like the imaginary part, which makes it complex. Okay. So let's get into breaking these down. So last time we learned how to just break down square roots. And now we're going to do it when there's negatives underneath. So whenever there's a negative underneath, you can write that as the square root of -1 times 144. Well, the square root of -1 is I. Okay? And the square root of 144, we could break that down to just 12 and 12. Boom, there's that 12. It pulls out. And then the square root of -1 is always I. Okay? So it'd be 12i. Let's do this one. So square root of -80. That's -1 times 80, which is the square root of, it's I, square roots of 80, because you can pull this out. So anytime you have a negative under a square root, you can pull out an I. Okay? But remember, I went over this in class, but if you have a cube root and there's a -1 under there, you can do that. That is -1 because -1 times -1 times -1 equals -1. Okay, if you're confused about that, ask questions in class. Now, we're going to break down the 80. So 80 breaks down to 2 times 2 times 2 times 5. We can just make a factor tree if you want, so that'd be like 8 and 10, which is 2 and 4, which is 2 and 2, and this is 2 and 5. So we can group those. So I'm going to pull out those 2's, which is going to give you 4i square roots of 5. Okay? Now this one, anytime you have a fraction underneath the square root, you can just break it up. So first we're going to pull out the I, and then square root of 36 over 21. That's the same as the square root of 36 over the square root of 121. The square root of 36 is 6. The square root of 121 is 11. So that's going to be 6i over 11. And you can get that by just putting this over 1 and multiplying straight across. Okay? Let's see. Okay, powers of I. This is super important. So I to the first power, that just equals I. There's not a lot you can do there. Okay? I squared, now we know that I equals -1. So if we have I squared, that means that we're just going to square -1. But if we square the square root of -1, you get -1. So I squared equals -1. I cubed, that's the same as I squared times I, which would be -1 times I, which is -I. Now I to the fourth, that's I squared times I squared, which would be -1 times -1, which is +1. Cool? Let's keep going. So I to the fifth, that's the same as I to the fourth times I. Well, I to the fourth is just 1. So 1 times I is I. I to the sixth, that's I to the fourth times I squared, Well, I to the fourth is 1. I squared is negative 1, so that's 1 times negative 1, which is negative 1. I to the seventh, that's I to the fourth times I cubed. Well, I to the fourth is 1. I cubed is negative I, which that ends up equaling negative I. Now, I to the eighth, that's I to the fourth times I to the fourth, which is 1 times 1, which is 1. Notice a pattern here, okay? I to the first and I to the fifth equals 1. I to the second and I to the sixth equals negative 1. I to the third and I to the seventh equals negative I. I to the fourth and I to the eighth equals 1. This pattern continues forever and ever and ever and ever. So, like, I to the ninth would be I. I to the 10th would be negative 1. I to the 7th, or I to the 11th, would equal negative I. I to the 12th would equal 1. So, basically what this is saying is the ones that are super important here. I to the fourth, I squared, and I. Okay, if you can remember that I equals I, which that one is a gimme. You definitely need to remember that. And then I squared equals negative 1. And then I to the fourth equals 1. If you can remember those three, we'll be golden. Okay? So let's look at I to the 11th. Well, that can be broken up into I to the fourth times I to the fourth times I third. Well, I to the fourth is 1. I to the fourth is 1. And then I to the third power is negative I. And you could also break this up into I to the fourth, I to the fourth, I squared, and I. So this is 1 times negative 1 times I, which would equal 1 times 1 is 1, times negative 1 is negative 1, times I is negative I. Ting. Okay, this one. So we're going to start by simplifying this down. So we're going to multiply 6 and 18 and get 108. And then the I to the 13th times I cubed is I to the 16th, because you add those exponents. Now 16 is divisible by 4, so we can just break that up into I to the fourths, which those are all technically 1, so that's just 108. Cool. Let's do this one. So this one we're going to raise the 2 to the 5th, and then the I to the 9th to the 5th power. So this is going to go like this to both of those. So that's going to be 2 to the 5th, I to the 9th to the 5th. So that 2 to the 5th comes there. Multiply those two, and you get the 45. Oh, sorry. So 2 to the 5th equals 32. I to the 45th. Well, that can be broken up into something that's divisible by 4. So 144 times I, which that's just going to be 1 times I, so that's 32I. This one, let's break down that square root first. So that's really 3I. Then we're going to cube that. So that's going to be 3 cubed, I cubed, 2 to the 6th, I to the 6th. Well, 3 cubed is 27. I cubed stays I cubed. 2 to the 6th equals 64. And then I to the 6th. 27 times 64 is 1,728. Then I cubed times I to the 6th is I to the 9th. Which that can be broken down to I to the 8th times I, which is just I. So 1,728I. Cool? Do those. H is a really big number. Okay, that was an accident. Sorry. Let's look at this. So, sorry, I want to go back. Sorry, I keep saying If you had x plus 2 minus 3x plus 4. We know that we just distribute the negative, and you have x plus 2 minus 3x minus 4, and then we combine like terms. So that would be negative 2x minus 2. Correct? We're going to do this same exact way. So we're going to combine like terms. So 6 minus 8 is negative 2. Negative 4 plus 6 is 2i. Pretty simple. This one, distribute that negative. So you get negative 4 minus 6i. Now combine like terms. Negative 3 minus 4 is negative 7. 5i minus 6i is negative I. Cool? this one we're going to distribute first. So we're going to distribute that in, like here. So 6 times 3 is 18. 6 times 12 is, or 6 times 2i is 12i. Negative I times 5 is negative 5i. And then negative I times negative 7i is 7i squared. Now, anytime you see an I squared, you have to plug in negative 1. So I combined the 12i and the 5i and got 7i. Now, I squared equals negative 1. Anytime you see an I squared, you have to plug in negative 1. So we're going to plug in negative 1 right there. And that becomes a minus 7. So then 18 minus 7 is 11 plus 7i. Okay, this one. Same exact thing as, say you had like 5. Oh, wait. Sorry, I'm way ahead of myself. So if you had 5 plus 3x and then 9 minus 8x, you would use the box to multiply this. And it would be 5 and 3x, 9, negative 8x. That'd be 45, blah, 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 blah. Right? Here, we're going to do the same exact freaking thing. So we're going to have 5 and 3i, 9 and negative 8i. 9 times 5 is 45. 9 times 3i is 21i. Negative 8i times 5 is negative 40i. And 3i times negative 8i is negative 24i squared. Now remember that I squared, we have to plug in negative 1. So that's going to be negative 24 times negative 1. Boom, that's where you get that 24. Then we can just combine like terms. So these two combine to give you 69. Those two combine to give you negative 13i. Cool? Okay, we're skipping those next ones. Oh, I forgot I did this. Those are my dogs, and I love them, and I just wanted to spice up my videos, so they're adorable. Her name is Aria, and she is the best. She's the biggest sweetheart. And his name is Aldebaran. And yeah, I hope you love them as much as I love them, and I hope this made you smile. Okay, continuing with math. All right, so 6 over 7i. Just like when we were doing radicals, we can't have i's in the denominator. That's one of those weird things where mathematicians are like, no, we cannot do that. That's bad. Okay? Because mathematicians think some things are bad. And i's in the denominator is one of those things where they're like, we can't do that. So we have to get rid of it. To get rid of it, it's really the same as when we had a radical in the denominator. We're just going to multiply top and bottom by that I. Okay? So that on the top, you're going to get 6i. On the bottom, you're going to get 7i squared. Now, we know that I squared is negative 1. So that's going to be 6i over 7 times negative 1, which is going to be 6i over negative 7. Then we can just pull that negative to the front. So that's going to be negative 6i over 7. Not too bad. Let's try another. So this one, we want to get rid of that I, so we're just going to multiply top and bottom by I. And that's going to be 26i, because this has to go to both of these. Okay, so that'll be 26i plus 4i squared over 8i squared. Now, anywhere there's an I squared, we're going to plug in negative 1. So that's going to be 26i minus 4 over negative 8, which is going to be negative 13, or 13 minus 2 over 4. We got to go back to that step. So if we have 26i minus 4 over negative 8. Now these can all be divided by 2. So I'm going to divide this by 2, divide this by 2, divide this by 2. And that's where you get this, the 13i minus 2 over negative 4. Okay. The last thing is we don't like negatives in the denominator. That's another thing that they're like, not cool, get that negative out. So we have to multiply top and bottom by negative 1. So that's going to be negative 13i plus 2 over 4. Oh, and this is something I forgot to mention. Write this down. Super, super important. Write this down. Look, I'm even using like a cool marker. Write this down. you have to write these in the form of A plus BI. 3 exclamation points. 3, that means it's really freaking important that you remember this. So A plus BI, it has to be in that form. It's another weird thing, but if you remember back to the beginning of the video when I said like they're written in this form A plus BI, that's how you have to write your answers, is in the form A plus BI. Okay? So here I just need to switch those two. So it's going to be 2 minus 13i over 4. Okay? You know what? Let's see. This seems like too much. So I guess we're done. I will go over the rest of that tomorrow. Remind me. I'll remember, but maybe remind me if I forget. And yeah, you guys are super awesome. Thanks for watching the video and buying into this because I promise it works. Okay, anyways, goodbye.